Good morning, children. Welcome back to the online session of a physics class. So we are discussing about the light lesson. So in the last class, I had explained about the refractive index, the relationship between the refractive index and then optical density. That is first point. The second point will be the relationship between refractive index to the speed of light in different medium, how it is related speed of light in different medium. Okay, so these two concepts I had explained how it is related. Refractive index is directly proportional to the optical density. That means if the refractive index is increases, optical density is increases. If the refractive index is having more value, then the medium will become more denser. Okay, so that is the first point. The second point will be the refractive index will be inversely proportional to the speed of light. That means if the refractive index is increases, speed of light is decreases in that particular medium. So that is about the second point we have learned. Okay, so after discussing these 2 points, I had done three questions. I have answered for 3 questions. So here are the questions. The first question will be: a ray of light traveling in air enters obliquely into water. Does the air bend towards the normal or away from the normal? Why? So when it is entering from air into the water, does the light ray bends towards the normal or away from the normal? You need to answer for that, whether it is ray bends towards the normal or away from the normal. So for that, you should know that which is rarer medium and which is denser medium. So in the air we don't have a much particles, therefore air will be the rarer medium. Water, we are having so much of particles, therefore water will be the denser medium. Okay, so here it is in the question, a ray of light will be entering from rarer medium to the denser medium. Whenever it is will be entering from rarer medium to the denser medium, okay, it will be bend towards the normal. Okay, since speed will be decreases. Okay, the reason is when the light is traveling from or enters from rarer medium to the denser medium, its speed will be decreases, therefore it will be bent towards the normal. So that is the reason for the first question. The second question, it is a light enters from air to glass having refractive index. They have given speed of light in the glass we need to find out. So medium will be glass. The first medium will be air, the second medium will be glass. So we should find out the speed of light in the glass. Okay, here the speed of light in vacuum they have given, speed of light in vacuum or speed of light in air, which because we will be taking the value as approximately equal. Okay, for the practical purpose. Okay, so third question, find out from table 10.3 the medium having highest optical density. Also find out the medium with lowest optical density, which is having highest optical density and which is having lowest optical density. From the table 10.3 that you need to say that. You can observe this. Here it is the table. Okay, so by observing this, we need to say that which is having highest optical density and which is having lowest optical density. Okay, so whenever the refractive index is increases, we are having a more refractive index, in the sense optical density is optical density is directly proportional to the refractive index. If refractive index is having more value, then the medium will become more denser. Here observe that diamond is having 2.42. it is highest value than any other material or medium here. So therefore diamond is having the highest density. Okay, so highest optical density, and air will be the lowest value, that is 1.003 of refractive index. The air will be the having lowest optical density. So air will be the lowest optical density, diamond will be the highest optical density, because the refractive index will be lowest and refractive index of air will be lowest and refractive index of diamond will be the highest. Okay, so that is about the third question. So fourth question will be, you are given kerosene, turpentine and then water. In which of these does the light travel fastest? Use the information given in table 10.3. So kerosene they have given, turpentine they have given, and water. In which of these does the light travel fastest? That means in which medium speed of light will be more, in which medium speed of light will be more, that we need to find out. That means speed of light and refractive index will be inversely proportional. Okay, so where we are having a refractive index is having a very less value, there the speed will be most, right? Speed will be most. Okay, so out of kerosene, turpentine and water, let me see which is having a lowest refractive index. So here it is, kerosene will be 1.44, turpentine will be 1.47, water will be 1.33. So water will be having the least refractive index out of water, kerosene and turpentine. So therefore in the water speed of light will be more or fastest. Here it is the fastest because here it is having a less value, therefore here it is having a speed of light will be fastest in water. Okay, so that is the conclusion for the fourth question. Okay, use the information given in table 10.3. Using that information we need to come to the conclusion. Okay, so fifth question, the refractive index of diamond is 2.42. What is the meaning of this statement? Okay, for this I had set the answer. Okay, so go through that answer. The answer will be refractive index of diamond is 2.42. Refractive index of medium, how it is related with the speed of light. Refractive index is equal to speed of light in air divided by speed of light in the medium. We know that. So what does that means in the sense? The refractive index of diamond is 2.42. This suggests that speed of light in diamond will reduce by the factor of 2.42 compared to its speed in air. Compared to speed in air, okay, speed will be decreased, speed will be reduced by the factor of 2.42 in diamond. Okay, so this will be comparing the speed in air with the diamond. Okay, so this will be decreased in diamond 2.42. Why it is decreased? In the sense diamond is having, it is having a dense, optically dense. Okay, so therefore here it is speed will be decreases. Whenever the optical density increases or refractive index increases, speed will be decreases. Okay, so that is the reason that. Okay, now we will move to the refraction by spherical lenses. Refraction by spherical lenses. Okay, so we have observed that reflection by spherical mirrors, reflection phenomena will be happened in the mirrors, refraction by spherical lenses. So refraction phenomena will be happened in lenses. Okay, so we have to understand that for the refraction, the optical device is for the reflection, optical device will be the mirror. For the refraction, optical device will be lens. So that we need to remember that. You might have seen you might have seen people using spectacles for reading. You might have seen that some people will be using the spectacles for reading. Most of you also are using the spectacles for reading. The watchmakers use a small magnifying glass to see tiny parts. For seeing the small parts, the watchmakers using a small magnifying glass. You can observe that. Okay. Have you ever touched the surface of the magnifying glass with your hand? Have you ever touched? Okay. If you have a chance to touch that, go and touch that. Okay. In the watchmakers also, in the watchmakers off also, or otherwise if you have a spectacles, you touch that. Okay. Is it plain surface or curved? Is it plain surface or curved? You verify that. Is it thicker in the middle or at the edges? Whether it is a thicker at the middle or it will be thicker at the edges. Okay. If it is a thicker at the middle, then it is a different type of spherical lens. If it is thicker at the edge, then it is a different type of lens. Okay. The glasses used in spectacles and that by watchmakers are examples of lenses. Okay. So where you can see the examples of lenses, lenses in the sense, the glasses used in spectacles and that by watchmakers are examples of lenses. These are the examples of lenses. Okay. What is a lens? How does it bend light rays? We shall discuss this in this section. So what do you mean by lens? Okay, how to define that, how to represent that. Okay, how it is bend the light rays. So all these things we are going to discuss in this lesson. Okay, so this one you can take it as a definition for the lens. A transparent material. Lens is a transparent material. Okay, it is a transparent material bound by two surfaces. It is having two surfaces, whereas in the mirror it is having only one surface. One is surface and another one will be, it is silver coated. It is not a polished surface, it is a silver coated. Only one surface will be the reflecting surface. Okay, so here it is the transparent material bound by two surfaces. Here I am having two surfaces. Here it is not a silver coated, one side it is not a silver coated. Both are surfaces only. Both are surfaces, of which one or both surfaces are spherical, forms a lens. Of which one or both surfaces are spherical, either one side or both the side are spherical, forms a lens. So this will be the definition for the lens. You can take it this as a definition for the lens. Okay, forms a lens. Okay, a transparent lens is a transparent material bound by two surfaces, of which one or both surfaces are spherical, forms a lens. Okay, this means that a lens is bound by at least one spherical surfaces. This means that a lens is bound by at least one spherical surface. It should have at least one spherical surface. If it doesn't have only one spherical surface also, then we can't able to say that it is a lens. Okay, if both sides are plane, in the sense it is not a lens. We can't say that it is a lens. Okay, so one side it will be a spherical surface and other side may be a spherical, or otherwise it may be a plane. Okay, if it is a plane, then it is called as a whether it is a convex or concave, it is called as plano-concave or plano-convex. If one side is plane and other side is spherical, then it is called as a plano-convex or plano-concave. If both sides are spherical, then it is called as double concave or double convex. Okay, so we have that a lens may have two spherical surfaces bulging outwards. Okay, this means that lens is bound by at least one spherical surface. In such lenses, the other surface would be plane. Okay, in such lenses, the other surface would be plane. So that is also a possibility. That is called as a plano-convex or plano-concave. A lens may have two spherical surfaces. It may have two spherical surfaces also bulging outwards. If it is bulging outwards, so you can see that it is bulged outwards, right? Both the surfaces are bulged outwards. Okay, bulging outwards. Such a lens is called a double convex lens. Such a lens is called a double convex lens. If it is bulged outwards, then it is called as a convex lens, right? It is a convex. Okay, since it is a transparent material bounded by two surfaces, of which one or both surfaces are spherical, since it is a lens, it is a transparent material. Okay, it is a double convex lens. It is simply called as a convex lens. If it is called as a convex lens, then definitely it is a double convex only. Okay, if it is one side will be bulged outwards and the other side will be, it is a plane, then it is called as a plano-convex. Okay, so if nothing in the sense you are calling just simply a convex lens, then definitely it is a double convex only. Okay, so it is thicker at the middle as compared to the edges. So which one? Convex will be, that is double convex will be, it is thicker at the middle. It is thicker at the middle as compared to the edges. So if it is thicker at the middle as compared to the edges, in the sense it is a convex lens. Okay, convex lens converges light rays as shown in the figure. Convex lens converges the light as shown in the figure. This converging concept I will explain you after that. I have to explain the ray diagram. After explaining the ray diagram, we have some standard rays. As usual, we have studied in the mirror also. Here also we are having a standard rays. Almost all are equal only. There it is reflection will be going to happen. Here it is refraction going to be happened. Okay, so those ray diagrams, before explaining the ray diagrams, I will explain those four standard rays. After explaining those four standard rays, you can easily understand this, how it is going to be converged, where it is going to be converged, why it is going to be converged here. So that you can explain after that, after explaining the ray diagram. Okay, as shown in the figure. Hence, convex lenses are called converging lenses. Here it is convex lenses are called the converging lenses. Exactly, it is the reverse process as the mirror. In the mirror concept, in the reflection concept, there it is concave mirrors are called as the converging mirrors. Okay, here it is convex lenses are called the converging lenses. Okay, similarly, double concave lens is bounded by two spherical surfaces curved inwards. If it is a concave lens, then definitely is a curved inwards only. Like this, it should be curved inwards. Curved inwards. It is having a both the side are curved inwards, so definitely it is a double concave. Okay, it is thicker at the edges than at the middle. It is thicker at the edge. It is not at the middle. It is thicker at the edge. Such lenses diverge light as shown in the figure. It will diverge the rays. Okay, light rays. Such lenses are called diverging lenses. A double concave lens is simply called as a concave lens. Okay, here also a double concave lens is simply called as a concave lens. If it is a concave lens, then definitely it is a double concave only. Okay, so this is some introduction about the lens, some basic definition about the lens, and then double or spherical lenses, that is convex lens and concave lens. Then double concave lens, double convex lens, plano convex lens, plano concave lens. So these are the things regarding the converging, which is converging lens. Convex lens is the converging lens. Okay, concave lens is the diverging lens. So these are the points you have to remember here. And then definition of the lens: a transparent material bound by two surfaces of which one or both surfaces are spherical forms a lens. So that is very important definition of the lens. Okay, so remember that. So after that, how it is going to be converging, how it is going to be diverging, I'll explain you after the ray diagrams. Then you'll easily understand that how it is going to be diverge, how it is going to be converge. Okay, so in the next class, similarly, some in the mirror, some terms will be related to the spherical mirrors, like center, radius of curvature, focus point, optical center. So these things and all we have in mirror concept. As usual in mirror concept, here also we are having some terms which are related to the lenses. So that I'll explain in the next class. Okay, so if you have any doubts regarding the today's video, you can call me or you can message me. Okay, so please make a note of that. I had sent the note for the above questions, 5 questions. Please make a note of that, write in your classwork. After that, write the refraction by spherical lenses, write the definition for the lens, then write the definition for the double concave lens, then double convex lens. Okay, and write which is converging mirror and which is diverging mirror. So these are the important points that you need to write in the classwork. Then these 2 diagrams I'll leave a space for that. I'll tell you when you have to write, then you can write that. Okay, so then how to represent the convex, how to represent the convex lens, how to represent the concave lens, that also you write. Okay, so thank you.